Hello everyone, my name is Austin Rovinsky and I'm an assistant professor at New York University. This is the 10th lecture in my mini course on physical design databases, and this lecture will be focusing on using the OpenDB C++ interface. Okay, I am at my terminal. This is an extension of the previous lecture on adding a new tool to a new C++ tool to OpenRoad. So if you haven't done the steps in that lecture, I recommend doing that first. So right now I'm in my OpenRoad folder, and I'm going to go ahead and head to the source folder for the new tool, which I have not renamed. It's still just called tool. We're going to head into source folder there, and then the main file that we're concerned with is this tool.cc. This is the one that we saw. If you recall, we saw directly the output of these printf arguments, or printf functions, in action. So this time, we're going to try to do something that actually interfaces with the database. So actually, I'm going to exit out of here. And the first thing that we want to look at for pretty much anything that we want to do is going to be the this file, which is the header file inside of OpenDB. So headed back out. So for our OpenRoad folder, we're going to go into source. We're going to go to ODB. This is the source folder for OpenDB, and then we are going to head into the include folder there, and then we'll just take a look here and see that we need to head again inside there, ODB folder. There's lots of header files. The one that we are concerned with is going to be db.h. So this is going to have tons of other functions, and obviously I'm already editing this, so I will just go ahead and open that up anyways. And so we can take a quick scroll through here, but you're going to see that all of the classes and things that we've discussed about in previous lectures are all in here. So all of the declarations, everything that's interesting is going to be listed in here. So we talked about one of the first things, or the top level class is going to be this DB database class. And so we can see right here, there's at least a few comments, usually for most functions in here, and we can see exactly all of the functions that we talked about. So we have some of our standard getter and accessor or setter functions. So we have getlibs, and this is going to return a set of db libs. We can even find a lib if we have a name that we can provide. We can get our tech files, our db techs, find a tech if you have the name for it, find master, and so on and so forth. And so what you can do is once you find the reference to the class of interest, then you can also look up that as well. So the task that I'm going to charge myself with is, let's say I want to make a tool which is capable of telling me how many instances are in my block. So something that's rather basic, and it makes use of OpenDB. So always we have to start from this DB database object. And then we'll need to find what are sort of the useful functions in order to get the information that we want. How can we access them? How can we modify them, etc. So we know that from our previous lectures, we have this database object, and then that is going to get us our chip object. And remember, the chip object doesn't really do much except for storing the database. So we will first take a look at the DB chip class and see what's in there. And there's a little bit, not really much. Create it, you can get it, and you can destroy it. And then the next thing you can do is get the block. So that's the next class of interest. We'll look up class DB block. And this one, as we mentioned, is a very large class. There's a lot going on here. So you can get the name of this block, whether you want it in a string or you want it in a constant C string format. You can get the bounding box of it. You can get a pointer back to the chip. You can get the database that it's a part of, the technology file that is used with it. There's a whole bunch of information. But if you look through this, the thing that we're looking for is something related to instances. And there we have it right there. There's this function, getInstances, which returns a set of dbInst. So we can use that, and actually this dbSet object works just like a standard template library set. So we can have a .size function, and that's all we really need, is that if we can say what is the size of this set that's returned, then that will tell us the number of instances in the design. So that's all we need in order to implement our tool. We'll go ahead and quit out of that, and then we'll head back to our source file. And then we can open up that tool.cc. And for right now, I'm just going to add this to this toolize function that we've already created. So the first thing that we need is a pointer to the DB. Fortunately, every tool knows this. And so what we have is already this member variable that's DB underscore. And then when it is initialized, it gets the pointer to the DB. So this tool already has DB, and it is pointing to the database as soon as this tool is initialized. So all we need to do is use that DB object. So DB underscore, and then this is a pointer, so we'll dereference that pointer, and the function that we want here is to get the chip. So we'll get the chip first, and that will return a chip object, and then we can just directly from there do a get block. And just to keep our code kind of clean, I'll go ahead and say that that's our block. So we have an auto, which is a nice way of not having to figure out what type it is, and we can say a block, and then it's going to be pointing to our block object. So from there, we need to figure out what do we need to do in order to get the instances. Well, so we have our block object, and then from there we can get insts. So that's going to return the set of instances, and from that, all we need to do is do a size call on that. So that will get the size of the set, how many instances are in that set. And let's go ahead, and we know that's going to be an integer number, and call this inst count. So we've done that, and then the only thing that we need to do is actually display that back to the user. So we can do, just to mimic the style that's above, we can do a printf, and then we can say instance count. Then we're going to print out an integer, and then inst count, which is the name of the variable, and then close it there. And so hopefully that should go ahead and work. So we'll close, well actually I will not close out this, I'll just throw that in another pane. The tool I'm using is called tmux, by the way, terminal multiplexer. I highly recommend some kind of terminal multiplexing tool if you are not used to it. It's very good for productivity. So unfortunately I'm back to my home directory, so I will go to OpenRoad Flow Scripts, I'll go to Tools, OpenRoad, that's where I was working, and then I will go ahead to the build directory. So that file is written, it's been modified, so all I should need to do here is run make. I'll add some threads to make sure it runs fast. And it's already gotten through really quickly, it already built it. And the next thing, remember, you have to do make install. Otherwise, your binary will not be updated. So it looks like it installed there, and it, again, make sure we're going to the right place. It did tools install, yep, so that's where I expect it to be. And then we need to go ahead and run that binary. I'm going to use a little trick here. So if we actually jump down to the OpenRoad FlowScripts directory, there is this env.sh, which is short for environment. And if we source that, what it will do is it will add OpenRoad, the OpenRoad binary that we've installed to our path so that we can call it from anywhere. We don't need to be in that specific folder. And so then I am going to make use of some of OpenRoad's test infrastructure to help us test things out. Well, actually, let's just try this real quick. Let's go to OpenRoad. Let's start that up. Okay, we're at our OpenRoad shell, and let's try doing the toolize. Still needs a command, or still needs an argument, so we'll try that. And segfault. So what obviously something went wrong there. If we look at our code, we will see that one thing we don't do is we do not check if this get chip or this get block actually returns something. So if you do not have your lib files, if you do not have your def files loaded into OpenRoad, then this pointer that returns is going to be a null pointer. There is no object to return. So it's actually very important to make sure that you have something loaded. And something that's important to fix this is making sure we have safeguard code. So making a nice user experience rather than having something that segfaults is good. So we're actually going to change this up a little bit. Instead of getting the block, let's first get the chip. And then let's have a little bit of error checking code. Let's just say that if the chip doesn't exist, so if chip equals null pointer, then we are going to print a nice useful message. So printf chip does not exist, new line character. And then we can also do that check for our block. So we can do auto block equals the chip get block. And we can just do a quick copy paste. So if block is null pointer, then we can do block does not exist. And make sure that we do something before it segfaults so we can just, in this case, let's say that there's nothing to do, so we will return in those cases. Okay, so we've added some safeguards. Let's actually just check real quick that this works. So first thing, of course, is we need to rebuild. So we will go back to Tools, OpenRoad, Build. We'll do a quick make. Then we will make install. And the nice thing is that it updated in place because we sourced the environment variable earlier. If we run OpenRoad, it should still point to that binary location. So we can go ahead and load it. And then we can try our toolize now with an argument. And then we get right here, chip does not exist. So we successfully tested for that. and we exited out safely. And now we're still back at our OpenRoad prompt rather than segfaulting and creating a bad state. So we'll go ahead and safely exit out of OpenRoad now. And then now we actually want to test this to see if it works. So we need a design loaded, and we will make use of OpenRoad's test infrastructure to do that. So there is a test folder inside the OpenRoad directory, and I am going to make use of one of these tests. Let's use GCD Sky130 hs.tcl. This one right here. That seems like a good one. It's a fairly simple design. So we will go ahead and start OpenRoad, and we will start it with that script. So we just provide it as the first argument, and it's nice and easy. So this is actually a test that will run the full flow, which that's fine for our purposes. That means what we'll have when this stops is that it will be at the end of the flow. So there will be a fully implemented design under the hood, even though there's no GUI, there's no visuals. But now, hopefully, we can run our toolize command and it will give us something interesting. So looks like I forgot a new line character at the end there, but we did indeed get an instance count, and we got an instance count printout. There are 7,972 instances in this design. So there you go. We were able to use OpenDB. We were able to add it to our tool and get something interesting out of it. So one last thing I want to show you is that through OpenRoad, there is actually a more formal method of displaying messages to the user, printing status informations and things like that. So I want to show you how we can add a logger to this tool. So a logger is very useful in OpenRoad because it can format things nicely to go into log files when you're looking through for status messages. It can help identify what tool is creating a message. It can help you pinpoint to where in the source code some certain print statement came from. So we'll go ahead and do that. So I'm in my tool folder and the sources folder, and the first thing that we actually have to do is go to our include folder, and we'll need to make some modifications here. So we'll open up tool.hh. So when we get inside this file, what we need to do is we need to take the pointer to the logger, because there's one centralized logger for all of OpenRoad, and then give that pointer to our tool so that it can use it. So we can actually see that this is the same way that our tool gets a pointer to the database. So we just need to make sure that we're also adding in a logger here. And so this is going to be a logger pointer, and we're just going to call it the argument logger. So one thing that we'll need to do is we actually need to forward declare this. So we'll have namespace. Typically this goes in the UTL for utility namespace, and then we'll say it's a class logger. I'm not sure why my editor likes to indent like that, but we'll make sure that that is forward declared. And then inside the tool, we'll have this nice using UTL namespace : logger. And so that will allow us to have that logger class declared, and it will input a logger pointer when we initialize the tool. The next thing that we need to do is, just like we have a DB variable that stores the pointer, we'll also have a logger variable to hold that as well. So keeping consistent with the style here, member variables of classes trail with an underline, so we'll just keep that here. So that should be everything for this file. And so that takes care of our header file. And then we'll need to go back down to the source directory and check out our, let's start with maketools.cc. Yes, so we can see here that our initialization function is just currently passing this Tcl interpreter and the database. So the way that we actually get the pointer is very similar. We have this OpenRoad object, and then we will just do get logger. And so that will return a pointer to the logger object that will pass it into our tool. And that should be everything that we need from here. Now we can go to our tool folder. So we're back where we were here. We need to actually make sure that, first of all, we have the right declaration here. We need logger, logger. So we're passing in the logger object, and now all we do is we simply say that our variable, our class member, is going to be equal to this logger that's being passed in. And so hopefully that should set everything that it needs to. And now that logger is going to be usable for everything else that our class has, all of our functions. So now we'll go down here and we will, instead of printing out the instance count, which I've already removed, then we will have this logger pointer. We'll do a call to it. And then we can say instance count. And then the nice thing about the logger is that it uses format strings. So if you're familiar with Python or you've used format strings before, you can use these brackets in order to represent a variable. And we will pass in that variable with inst count. So there are a couple things that we need to add here. One thing that the logger in OpenRoad requires is saying where this message is coming from and giving it a unique identifier. So there is a dedicated list of tools, and our tool that we just created isn't on it, so I will be a little bit lazy and just say that this is a utility function, UTL. So that's the identifier. It's an enum identifying where it's coming from. And then you need to use a unique number. Ideally, you should look at the messages for this UTL class and see what numbers have been used and just try to increment sequentially. That's best practices for contributing to OpenRoad. But I will be a little bit lazy and just pick something that probably hasn't been used. So we'll go with 999 here. And so we'll see this all in action, hopefully, in just a moment. So I will go ahead and just quickly open up a new pane, go back to OpenRoad, go to our build folder, and then do a make. And maybe if we're lucky, which we aren't, we'll see what happened. So it's saying unexpected. So chances are I probably just forgot a quick semicolon. Let's open back up our tool. And it turns out I forgot the critical point of making a function. So there are a few different ways that you can call a logger with different status messages. You could call it with info, which is going to just say this is a normal sort of status message, nothing special about it, just returning some information. But there's also a warn class, which is a little bit sort of elevated. It's supposed to alert the user that something is not in the expected range. And then there's also error. When you call an error, it actually works a little bit differently. Not only does it print the message, but it will throw an error and return all the way back to the the Tcl interpreter, the prompt for the user. So it will stop and halt all processing of this function that you're inside, but it won't exit the program. And then there is very seldom used, I believe it's either crit or critical, perhaps, is another level which will immediately exit the program if you are doing something usually deep in the database where it's not recoverable from that error. You cannot go back to the Tcl prompt because something very unexpected has happened. But usually we don't use those. Here we're just reporting something normal, so we'll stick with info, and hopefully that will resolve this error that we see. So it got through building, and we'll remember to install. And let's see. It looks like I lost my environment really quick here, so I'm just going to do a source and get back my environment. Okay, so now OpenRoad is sourced, so I will go away from the build folder. I will go back into the test folder and call OpenRoad on I think we were working with Skywater 130 HS. We'll call that script. I'll maximize my screen so we can see everything. And then this will finish up, and then hopefully we'll try our toolized script, and there we go. So now instead, our last message, it's printing out this nice formatted message. The new line is automatically inserted, so that's great. But you can see there's an info tag. It's identifying the UTL function where it's coming from. It has this unique identifier 999, which is useful for looking up where this message occurred in the code. And then it's got our message that we printed out, the same 7,972 instances that we found before. All right, so that's it for this lecture. I'd like to thank Nordtech for sponsoring this lecture series and making it available. And I'd also like to thank you for watching. So I'll see you next time.